Hi everyone, this is Sri Devi, uh, Professor, Department of Electronics and Communication Engineering, Rohini College of Engineering and Technology. In this video lecture, we are going to learn about diversity in wireless communication. On completion of this module, the learners can able to understand what is diversity and what are the effects due to diversity. Before that, we should know what is the fundamentals of diversity techniques. Diversity means it exploits a random nature of radio propagation by finding independent signal paths. It is for communication. Different paths can be calculated, find out, and it is to improve or to boost the instantaneous SNR value. So all these are to increase the signal to noise ratio value. Some different paths are calculated. Diversity is a powerful communication receiver technique. It is simply a receiver technique and it is used to improve the signal to noise ratio that provides wireless link improvement at relatively by low cost. It requires no training. So diversity scheme is a method that is used to develop information from several channels transmitted over independent fading paths. Simply, small scale fading causes deep and rapid amplitude fluctuations as mobile moves over a very small distance. If we space two antennas at 0.5 m, one may receive null while the other receives a strong signal. By selecting the best signal at all time, a receiver can migrate or reduce the small scale fading. This concept is called as antenna diversity. In virtually simply, this diversity complex is applicable in all applications. For example, you can consider a receiver. The receiver should be designed in such a way that it should give a best signal to noise ratio. So there are receivers designed by different diversity concepts, basically upon two types. One is microscopic diversity and another one is macroscopic diversity. Microscopic diversity is nothing but which is related to small scale fading. Fading means that is the path loss, and the macroscopic diversity it is referred to the or related with the large scale fading, that is path loss. Microscopic diversity, small scale fades means a deep and rapid amplitude fluctuation over distances of just a few wavelengths caused by multiple reflections from surrounding in a vicinity. What's the meaning of this is microscopic diversity means the change is very little, and so the fading effect is also very simple. It was determined by ray length, so that it is called as ray length fading distribution of signal strength. Microscopic diversity techniques can explore it with a small rapidly changing signal, and for example, two antennas at the receiver separated as a fraction of meter. So one may receive null, another one receive strong signal. Thus, selecting the best signal at all times, a receiver can migrate small fading effects. It is called as antenna diversity or space diversity. Example for this is called as rake receiver. So here, as we said, two types of antenna, both can be received at a time. That is, one can be full with the full strength and another one can be with null. So that is by aim is by selecting a best signal at all times, that is called as the receiver's target, and can migrate small scale fading effects called antenna diversity or space diversity. Example, it is rake receiver. Macroscopic diversity means it is also useful in the base station receiver. By using base station antennas, there are sufficiently separated in space, so base station is able to improve the reverse link by selecting the antenna with a strong signal from the mobile used to make slow fading. So samples are base station standoff and in cellular networks. Derivation of selection of diversity improvement. Here we are having some switching demodulators with gain G1, G2, G3 and amplifiers buffers 1, 2, 3. So here through this M independent relay feeding channels available at the receivers as in the figure. These channels are called as diversity branch. So by here each branch SNR is given by SNR equal to EB by N naught, and polarization diversity means here it is based upon that base station space diversity is contrast less practical, and here decorrelation of signals in each polarization is causing multiple reflections between the mobiles and base stations. So frequency diversity is employed in the microwave LOS links. Due to that some deep fading effect occurs. So in practice 1:n protection switching is provided in radio licenses to make this proper. Disadvantage, it is not requires separate uh, yeah, that is requires separate bandwidth, also requires that main drawback or main disadvantages. It requires spare means some different some more, so but also it requires many receivers, so that some critical traffic may be there. Time diversity means it multiple receptions, multiple signals will be received in an independent fading condition, that is called as time diversity. For example, rake receiver for spectrum of CDMA. So in this session we understood what is diversity and what are the diversity